All right. Hello, AgentConf. It's so great to be here. First time this conference, first time in Austria, and it's amazing so far. And I would like to start with asking you a couple of questions, okay? Are you there with me? So raise your hand, or actually two hands, if you ever fixed a bug. All of you did. Amazing. Now, raise your hands if you fixed a bug and write regression tests for it. Okay? That's still pretty awesome. It's like half of you. And now, have you ever fixed a performance bug? Yeah, we're here to fix our clients' or products' performance issues, right? And let me ask you, have you ever write a performance regression test for your performance fix? Yeah, I see a couple of hands. Yeah, I wonder what tools you're using, but reach me out later. So this is what I want to talk to you about automated performance regression testing in React. So my name is Michał Pierzchała, or Michael. I work at CallStack, where we do open source in the React Native community and consult React and React Native apps for our clients. My job is to make sure that we keep doing the open source bits. I've contributed to a bunch of libraries like Jest, React Native, testing library, and you can find me on the Bird side or the Toot side, although I'm active on the former one. You've probably seen stats like this, where those big companies lose billions of dollars yearly on performance issues when their sites are loading slowly or results are not fast enough. And let me tell you that performance actually matters. It's not only for the big companies like this, it's for us, for regular users. Slower load times for the web apps lead to less sales. Heck, users would give away those beautiful animations, like most of the users, if they could finish their tasks faster on your website. And it's also not only apparent to websites. Mobile apps have exactly the same problem. So why I'm showing you this? Because I would like to get you through a journey there and not really back again, a journey from not testing performance to how testing it changed the way that we work. So it starts with a few one-star reviews for some company called X. This is for their main app. It's on Android, so you get some of the fake screenshots from the Android Play Store. And not diving into details, this app was really slow. Users were complaining mostly about performance. So they reached out to us. Hey, can you fix our one-star reviews? And we politely answered that that's not really possible. And then they picked an ace because they said it's a React Native app, and it's really slow. And we're considering rewriting it to Flutter, this React Native alternative. And this got us triggered a bit. But then a few deep breaths later, we started a real conversation and got our team to improve it. No. So the time and money was spent, bugs were analyzed, performance issues were fixed, performance was improved, and everybody was happy. And then they messaged us back again. Hey, you there? Yeah, what's up? We didn't tell you everything. Like, it was not the first time it happened. What do you mean? Well, we had the same issue a few months ago, but we had to ship fast, right? And some things broke, apparently performance. And this actually got us thinking how we can prevent it so it doesn't really happen again in a few months after our fixes. So we started to plot this chart over two axes, time to spot regression and the testing granularity. And from before to after release, and from end-to-end to unit testing. So we started to put some tools on there. We have Lighthouse, which can do a bit of both, testing end-to-end of our apps before and after release. We have Page Speed Insights, which takes like 28 days to get the data, but it's pretty accurate on the real user data. And speaking of real user data, we can instrument our apps with real-time user metrics instruments like Firebase or Sentry. And on this end-to-end testing spectrum, before release, we can use Hyperfine if we're having a CLI app. There are also feature flag services, which kind of resemble some unit testing in production that you can throw at your users. But what about this space? Before release, unit testing. This is something that we haven't really found or haven't really known at the time a good tool for doing so. And we wanted to prevent regressions before they hit our users. And since it would benefit this company, one of my teammates started to prototype it. And what you see here is an internal issue. And this is like part of the culture that we have that I'm really proud of. Because any developer can file a R&D request like this, which usually revolve around creating some tools, fixing someone else's problems, and open sourcing it eventually. This tool was already prototyped for a client, and Maciej here, who is the maintainer of the React Native testing library, by the way, right behind those bots, dependent bots, I see you. So Maciej requested some time of the project just to prepare this this new tool that he worked on to open source. And so I asked him if he thought about turning it into some kind of performance testing library for React. And he said, yes. At the time, I ran a small survey to see what kind of performance issues my colleagues deal with daily. And there were slow lists, rendering issues, heavy SVGs, unnecessary re-renders, use effect, some outdated libraries. Yeah, it's pretty React Native specific, but that's all right, because if we look at the origin of issue point of view, we see that most of this is yellow, and yellow is JavaScript. But what about the frequency of the answers that I got from my peers? Still, mostly JavaScript. So 80% of the time our developers spend fixing performance bugs is spent in JavaScript realm. So most issues originate from React misusage and unnecessary re-renders. And hey, React, that's quite a lot of re-rendering problems after 10 years, right? But I just wish everybody went through Nadia's re-rendering guide, but that's actually not the case. So anyway, we can from this data, we could see that only the rest is React Native specific data transfer hiccups and some native code problems like rendering too big images or database connections, which are working inefficiently. So React is also where most of our so-called business logic lives, which changes all the time. And it changes way more often than those native libraries and frameworks that we built on top. And if you replace native with DOM, you'll get the idea. So anyway, we started Googling, researching for React performance testing library, and we found this. So it's named pretty nicely. So let's see what's inside. It wasn't quite popular at the time. It wasn't today either, but that's okay. It wasn't recently updated as well. What drove us down was it was monkey patching React, which we didn't really like. And because of that, they stuck on upgrading to React 18 in 2021. And I can't blame them. There are bigger libraries that had those same problems, right? Please don't get me wrong. I'm not here to bash on maintainers. I have so much empathy to them, and I'm also I'm also a maintainer myself. And it's just a really hard job keeping up with upgrading the tools that we build on, especially if we rely on some kind of I remember. I'll need you on this one. Of course. The implementation details. Thank you. So anyway, we still need our React performance testing library. And we actually built it. And 2 months of legal work later, we finally got our client's approval. It was basically ready for open sourcing. Just few days before the library that I was going to announce the tool. So thank you, that wasn't stressful at all. But it happened, we released, and nevertheless, I would like you to get familiar with the idea of performance testing in React and how it can look like. So let me briefly show you what's possible with this library. Reassure builds on top of your probably existing setup with React testing library. We add some small performance measurement API on top of it, and that's it. That's all you have to do to write your performance test. It's designed to run on a remote server environment and as a part of your continuous integration suite, because running on your computers doesn't make much sense. Everyone uses different machines, can't compare between those. And it also integrates with GitHub to enhance the code review process, thanks to Danger.js. And we could probably use some other commenting bots, but Danger is a library from my friend Orta, and good friends use each other's tools. So that's what we do. And let's take a look at this example. We have a counter perf test TSX file, which is like a copy of our regular test. And it's a React testing library code inside a scenario function. And this scenario is used by the measure performance function that we have from Reassure. And in this example, we render the counter component under the hood around 20 times because we tell it so. We wrap it with React Profiler API. This is what runs under the hood. There's no like magic there. And this is usually what you have to write. Copy paste your existing tests, instrument with this measure performance function, and forget about it. And I would like to share some insights on creating a performance benchmark in JavaScript, because it's particularly tricky in JSVMs. So the key for a good performance benchmark is having stability and avoiding flakiness between the test runs. So to do that, we need to take a few actions, like take JIT or garbage collection or module resolution caching into account. We also have the cost of concurrency that our test runner is using. We need to pick what values to average, what to percentile, whatever that means, and a lot more, actually. So we're doing this under the hood so you don't have to build it yourself. So take statistical analysis, for example, to make sure our measurement results make sense mathematically. We can't run them once or twice. We need to run them many times. So we figured that 10 times is a really okay baseline. You can adjust that. And then to determine this probability score, we need to make sure to calculate the z-score. It needs some average, it needs divergence, it needs standard deviation. Nothing you should care about, to be honest. And on this spot, I would really like to thank the VA team for their micro benchmarking tooling in their C suite and written in Python. We used that, converted to JavaScript, so we also didn't have to think too much about it. And measurement precision is another tricky topic in the JS land because imagine that React Profiler uses performance.now API to, let's say, reliably measure rendering time. And Node.js implements this W3C standard recommendation, which, due to privacy concerns, requires a resolution of no less than 5 milliseconds, which means that we can measure 1 millisecond render with at least 0.5% error. And this is usually good enough, but some components can render faster. That's why we run them multiple times anyway and let you configure so as well. So this is interesting. This is an actual implementation of the performance now in React Native. It's C++ based because it's a cross-platform code base. If you can spot a bug or two, there are at least two, let me know after the talk. I'd like to talk to you. And having all of this data, we can present you the render duration times and whether they're statistically significant or meaningless. We can also show you the render count, which React Profiler gives us for free. All of this information is stored in JSON, performance analysis, but we can also put this in Markdown file, which is actually the source for the commenting bot run with Danger.js I just mentioned before. And yeah, this is by far, I think, our favorite way of using Reassure when it can comment on your pull request and tell you that something is probably off or it's probably not. So now I would like you to see this in practice for a small suite of performance tests that we have. And before we start comparing the result, because Reassure is all about comparison, measuring and comparing so we can see if we have the regression or improvement, we need to calculate the baseline. So the first time working with it, we call it with the baseline flag. And Reassure runs Jest, or it can also run Vitest through Node.js under the hood. And it's called with some special flags that Node enables and allows us to pass to V8 further to increase stability. And the measure performance function runs the React Profiler to handle measurements and allowing us to avoid monkey patching React, really. So once we're done, we have the baseline results. The tool tells us you can now run Reassure without extra flags. So let's do it. Now we run it on the same branch again to see if it can detect any meaningful changes in the code base that haven't really changed. And we see every change is meaningless. So there's no change in the render count. It's still 4 or 7 for some of the components. And there is like small variation due to the stuff that I'm running on my machine. Now, so let's let's turn off this artificial slowdown that we had in our slow component example and run it again. So it will take a while because Reassure is actually running the same test 10 times or 20 times, depending on the case, depending on what we told it to do. And after it's done, it can tell us that, hey, there's some green stuff happening here. It's good. It's good for you. It's good for your code base, good for your users. And we can actually notice we dropped render counts from 4 to 3, and this resulted in 25% or 14% faster components that are related to this change. Pretty nice, right? From one less re-render. So where to put the performance test on this fancy trophy by Kent? I'm really thankful to Kent for this instead of the pyramid. It works way better for the front-end code bases. And so front-end performance tests resemble end-to-end tests for our apps because they're so slow and at the same time they're being run in an emulated environment. So I think they're just right below end-to-end tests, above integration tests, which means basically write a bit of them, but don't get too crazy, or your CI bill will be, well, bigger. And I think we could consider treating performance of our app as a process itself. And funny thing about processes is that they're subject to optimization. So in 1986, some smart folks at Motorola came out with this data-driven improvement cycle to optimize business process called DMIC, which stands for Define, Measure, Analyze, Improve, and Control. So let's see how we can apply this in our software cycle. We usually defer definition to our POs or project managers, and this is actually a critical step to understand what exactly we want to improve, so it actually makes a difference for the app we're working on. We think we measure, but usually not, unless someone makes us to. It's easier to read some hot take on Twitter or YouTube and see some micro benchmark, get your opinion on that, and not measure yourself. It's just easier to do. We're actually killing it at developers at analyzing where the performance issues are coming from. In deep diving, we're just good about it, no question. And improving the state of things based on this analysis, we're also pretty good at it. We sometimes even use measurements for that if someone really can't believe us. And we're actually terrible at controlling the performance because we're not testing it. And if we do, it's rather accidental than intentional, and usually lacking in a sense. So this is where tools like Reassure, Lighthouse, real-time user metrics can help us. They can back you up and ensure you're heading towards more optimal code. And we like this structured approach that we even wrote a dedicated chapter in our chapter on this topic in our React Native optimization guide. And now we teach our developers and our clients' developers to do the same. And yes, we've written 200 pages ebook on optimizing React Native. Don't ask why. On this note, I wanted to give a small shout out to my friend, Mike Hudiak, whom I learned about this technique and the process optimization. And he actually shared his insights on the React Native EU conference. And he told me he got inspired by this little tool we were building at the time. And once we open sourced the library, another colleague of mine from BAM, Alexandra Moreau, messaged me he liked Reassure's measurement API so much that he decided to adopt it in his own performance profiler for Android, like end-to-end tool. And recently it was rebranded to Flashlight. It's a really cool tool. If you're doing React Native apps, go give it a try. And they have the aspiration of being Lighthouse for mobile. And it allows for writing tests as well. So yay. Yeah, so a book, a talk, and a product all influenced by this small library that only get like 3K downloads a week from NPM after 8 months of publishing. So I think it's not too bad, right? And after all, maybe it's not all about numbers, but the ideas that we propagate. And the impact we can take on the industry to make it better, one step at a time. I like to believe that. So what I also like to believe is that it's only the beginning to make the performance testing so easy and delightful and natural that no one even questions it, to make it a culture. Because culture is better than processes. Because this library wouldn't exist if it wasn't for the open source culture we built over the years. And without people like Maciej, who, by the way, is too shy to talk about it on conferences, so I'm doing this part for him. But we'll get there, I hope. And in the meantime, please follow his work on Twitter. He works really hard, and he's dedicated to this React Native testing library, so he'll appreciate that. And Reassure is on GitHub. Give it a star. Try it after the conference. Maybe not now. Pay attention to the talks, and give me some feedback. Just try it. Create issue in our GitHub issue tracker. We'd love to hear it. And thank you.